So I'll take us through kind of a few main things today. Firstly, what is a smart contract? Why are they important? Then, why does Stratis need to go and build our own smart contract platform? And how is it different from existing platforms like Ethereum? And finally, I'll give you a bit of an insight into kind of where we're up to in our platform's development. So a bit about myself briefly. So I've long been a .NET developer. For me, this meant basically building kind of enterprise level government applications back home in Australia. So often using kind of C# and whatnot. So I loved this ecosystem, and I kind of fell in love with it because you basically have one tool, Visual Studio, inside of which you can debug, test, and deploy your code. You have a really amazing developer community, a really beautiful language, C#, and just really good best practices, strong security principles, and things like this. So I came from this ecosystem, and early last year started building on top of Ethereum. So if you're familiar with Ethereum, smart contract development on Ethereum requires you to use most likely Solidity. So in contrast with what I was used to, Solidity is kind of really young. Ethereum as an ecosystem is really young. A lot of the tools are completely brand new and often kind of experimental. There's still a lot of work to be done there. I was really frustrated by kind of the whole ecosystem and the whole environment and just wanted to kind of improve it myself. So I started building a C# to Ethereum virtual machine compiler. So the idea here was that I could take the language that I loved, C#, start compiling the code, and ultimately get to a point where it would run on the Ethereum virtual machine. So this actually worked. It worked really well. But I came up against one kind of really big problem. I'm taking this code that people know how it's expected to work for maybe 15 years, and now running it in a completely different instruction set on a completely different virtual machine. This is a problem because there's no way I can ever guarantee that it's going to behave in the same way. And moreover, I can't really use all of my favorite tools because kind of all of the other levels on top of that virtual machine are completely different. So I ultimately have to kind of halt this project, but very fortunately I was well in touch with the guys at Stratis around this time, and we realized that we could work on a kind of a smart contracts platform that was .NET from the ground up. So Stratis then, basically what we do is we provide now a platform for building blockchains. So it's completely developed in C# and .NET, and it's built to be as user-friendly and developer-friendly as possible. The barrier to entry for blockchain development is just extremely high, and we just really want to lower it. So we kind of build a bunch of things. It starts with mainly a modular full node, so you can kind of build any network that you need to. You could build your own blockchain at home, maybe plug in proof of work, plug in proof of stake, maybe you want it to be a side chain, maybe you need smart contracts. All of this can be really easily done in one kind of C# code base. So on top of this, we're then building, of course, things like smart contracts and side chains. So why are smart contracts cool? Why do we need them? So you likely know that blockchain applications are important because they can be decentralized, they can leverage a high degree of immutability, and have really high transparency as well. So you might be out there, you might have a really great idea for a decentralized application, but if you had wanted to build that maybe a few years ago, you have to go through this really long process to do so. So imagine you wanted to build out, say, an auctioning platform that was peer-to-peer. So any individual can come and start selling items to any other individual. Anyone can come and try and bid and try and buy items. And there's no intermediary middleman that's facilitating this interaction. So what we can do is, of course, build a blockchain application to try and remedy this. What we would have had to do is take something like the Bitcoin core node, go and alter the consensus rules, go and alter the code to somehow build our new functionality in, this auction-related functionality. Then after this, we would have to somehow hope that we can tell enough people around the world to start running this code. Because blockchain, of course, is only useful when you have hundreds or thousands of nodes around the world running your code. This last part is really the difficult part. It's obviously not scalable. If all of you people are out here and have a really great idea for a blockchain application, there's just no way you can convince me to run all of your programs at once. So you need some kind of way to fix this scalability issue. This is where smart contracts come in. So kind of formally defined, smart contracts are snippets of code that extend the functionality of a blockchain, allowing it to map out complex financial interactions through the sending of funds and storage of data. What this means for our auctioning example is anyone out here could build out some auction-related smart contracts, deploy them to one single blockchain, and this single blockchain now has more functionality than it did before. So they kind of make blockchains general purpose, and it relieves the need for like all these different blockchains for all different kind of use cases. So there's a range of really exciting things you can do with them. Obviously, I've just touched on auctions. You also have tokens. Of course, everyone is likely aware that many of the tokens or the coins you buy now are actually sub-currencies. So they exist on smart contracts on another chain, usually Ethereum. You also have examples like peer-to-peer lending and betting, where we're trying to remove some central intermediary. We obviously don't need this financial intermediary to facilitate the interaction in all cases. So in something like lending or betting, kind of every individual inside the interaction can bring much more value. Then getting down to the really complex side of things, you also have areas such as digital ownership of property, where maybe assets can be pegged on chain, and self-sovereign identity. So this is an idea where individual identity can be stored on chain, everyone manages their own identity, and rather than data being kind of managed by some organization, you control it yourself and give it out in like a cryptographic way. So imagine you're us, imagine you're Stratis, and you actually want to build a smart contracts platform. This is where it's really difficult. So it's a really tough problem because you need to have nodes all over the world that need to be able to execute any kind of code, no matter what code any developer wants to upload. Yet at the same time, all of these nodes always have to agree on the outcome of the code execution. So to fix this tough problem, the very first solution was to build a custom virtual machine. The best example of this is the Ethereum virtual machine. It basically has a completely limited instruction set. There's only very few things you can do. There's no kind of calls to an outside website, for example. You can't find out any information about the underlying architecture. You can't find out any information about the underlying operating system. So it's constrained tightly at the VM level. Moreover, because they own the VM, they can also build into a resource tracking. So we'll talk about why this is important soon. But basically, VMs need to be able to track the amount of storage used, the amount of instructions run, and the amount of memory used, because for the node that's executing this contract, it's actually costing them something. So this approach works at building a completely new VM, but it manifests in a completely new ecosystem. So this is why you see things like Solidity and Serpent. This is why you see completely new development environments. And this is why, basically, coming back to my initial problem, I couldn't use any of the tools I knew and I loved, because this base layer down the bottom was completely different. So at Stratis, we took a completely different approach. We decided that from the beginning, we would use the .NET VM, which is the CLR, so the Common Language Runtime. And we don't control it, so we can't quite constrain it like the EVM is. However, we can constrain the code that runs on it. So before any contract is deployed, we just ensure that it meets some certain characteristics, that it's always going to execute in the same way no matter what, and it allows us to use the CLR, so the .NET VM. And we obviously need to be able to track resources as well, and this isn't done natively in our VM. So what we have to do is we do something really magical, I'll speak about it in a sec, where we inject a small amount of code and we can still get those up-to-date metrics of kind of how much storage, memory, and CPU instructions have ever been used. So these are some really tough problems, but once we're able to fix them, we actually have a really cool result. So unlike the Ethereum ecosystem, we're able to leverage an already existing ecosystem. So for us, this means C#. It means I can use C#. It means in the future, we'll be able to use F# as well. It means we can use Visual Studio to debug our contracts, to test them. And it means in general, we can basically do everything that .NET developers are used to. So things like decompilers, code editing, code analysis, all these kinds of things. If .NET developers already have the tools, they can use them on our platform. So you might be asking, like, why this obsession with .NET and C#? So for us, there's kind of a range of reasons. The first reason, we have access to a much larger pool of developers off the bat. So there currently maybe is not so many developers around the world that can audit code like Solidity. However, for us, we have developers kind of all over the world that already know C#, so they can already jump into smart contract. Also, faster ecosystem growth. If we have more developers that are able to develop on our platform, they're going to be able to provide the best applications, and people are kind of going to be drawn to us. We also have integration with the .NET ecosystem. So again, this is what I keep talking about, that all these tools are already available, so they can be used on our platform. So for example, we have unit testing in C# inside Visual Studio, and also smart contract decompilation. So for any single contract, you can actually see the entire source code that exists there. It's the entire real C# source code, as opposed to in Ethereum, only about 1% of contracts have source code of it. For the most part, you're looking at just bytecode, which is virtually impossible to debug. It's virtually impossible to try and understand what it's doing. And of course, down the road, there's going to be some really big performance benefits for us as well. We're able to leverage, again, a lot of existing tools that are already out there. And the final big thing is F# in the future. So F# is C# functional counterpart. It's really exciting because it's used a lot in finance, in the government sector, and it has really important benefits for formal verification down the road as well. So I'll just speak quickly about those kind of two problems that I mentioned in terms of getting the VM ready. So what we had to do to ensure deterministic execution, and just reminding you what that is, it's basically this idea that contracts need to be executed in the same way every time in every instance of the program running. So you have, for example, my computer might be a 64-bit Windows machine running at home in Australia in English, and it needs to still communicate and achieve the same result as maybe a 32-bit Mac that's running maybe in China right now. And so how can we ensure this? So what we do in constraining the code is we ensure that for some certain properties. So firstly, only limited libraries within C# are allowed. So off the bat, we only allow system and Stratis.smart contracts, which is our custom package. So there's no network, operating system, or architecture calls, so you can't make any calls kind of externally. No floating point arithmetic. This is because in the arithmetic around floating point numbers, you can actually reach a different level of proximity in the last few numbers. This can be a source of non-determinism, so we just rule that out. No threading. Obviously, if machines are running code in kind of a different order, it's impossible for us to pick what that will be, so we don't allow threading. And no finalizers. So the garbage collection in .NET is actually not deterministic. So to kind of deal with this, we just enforce that anytime an object's destroyed, you can't call any code, which is what would happen inside a finalizer. And so the other hard problem then is resource tracking. So again, contract execution actually costs you something. So if your node is executing a contract, it costs you some memory, some storage, and some CPU time. You need to be kind of like receive some value for that. So for us to calculate this, we have to kind of do some magic, and we inject a small bit of code behind the scenes. And so there's a kind of a related problem here as well, which is that of infinite looping. You can imagine that if a contract gets into an infinite loop, it's going to run forever, and this node is actually never going to be able to catch up with the rest of the network because it's never going to finish executing that code. So we just need some way to kind of tally how many resources are being used, and ultimately stop execution if we get past a certain amount of gas peaks in that. So how we do this, so some of you probably really don't want to see code, but if you're a developer, basically what you would write is something like the code above, at the top. What actually happens behind the scenes, though, is you'll notice we have these, next to the red arrows, these spend gas pools that are kind of injected. So depending on the amount of computations that's being executed around this area, in each individual block, we just kind of spend a certain amount of gas. And gas is this idea of how many resources are being used. It's kind of a metric of how much resources are being used at a given time. So obviously those were the kind of problems we had to solve, but this got us to a point where we were able to release our smart contracts alpha on the 14th of May. So we released a bunch of things around this time. Firstly, a proof of work smart contract node, a NuGet package, Stratis.smart contracts. So this is kind of anyone can go and download this inside of Visual Studio or just download it on their own and start using it to build smart contracts in C# really easily. A command line validation, compilation, and deployment tool. So this is something that you can kind of, obviously nodes are going to be validating your contracts. You'll be able to use it to validate your contracts as well before you deploy it. A range of documentation we've put out as well, and a smart contract template for Visual Studio. So if you're a developer inside of Visual Studio, you can just hit File New, and just like you would create a console application or web application, you can now also create a smart contract application. So we put a link here to our documentation if you want to know. So we've had a range of cool contracts that people have been building so far. So to give you an idea, the first one is a mintable token. So this is cool because it's kind of like an ERC20 equivalent from Ethereum that's being built in C# on Stratis. We have an MFN multi-sig wallet, so if there's maybe 5 of you and you want to only be able to send funds when 3 people agree, this is being built in C# as well. A zombie factory, so it sounds a bit weird, but it's one of the very first tutorials that people do inside of Ethereum is to build collectibles. The one widely known one is this zombie factory. And kind of the fact that someone has already built this in C# kind of shows that we're pretty much on par with Ethereum. And also a World Cup sweepstakes. So this is ongoing at the moment. A bunch of community members have put a bit of a pool together, and we have kind of a sweepstakes running between all of us. That's kind of completely self-executing as part of the smart contract. So we have a bunch of stuff coming out in the future. Where we're looking to get to is basically a mainnet proof-of-stake sidechain. We also want to have a Visual Studio integration for inline feedback. I kind of mentioned we have maybe some command line tools earlier. All of this should instead actually happen inside of Visual Studio. We'll have some smart contract standards. So you may have heard of, say, ERC20. We'll have our own equivalents, which are very easy to kind of inherit from inside Visual Studio again, and you can start writing kind of standard contracts. We're also going to be allowing developers to test contracts on a local development chain. So it's currently quite difficult to actually spin up your own chain or join a testnet to start testing your contracts. So we're going to try and improve on this with like a local development environment. Front-end libraries for pretty applications. This is an example similar to Web3 in Ethereum. And the final thing is F#. So F# really exciting, as I mentioned, because it has this kind of counterpart language, which is F*. So F* is a very experimental language being kind of driven by Microsoft. And it's exciting because you can mathematically prove that for any input of your program, it's always going to behave in a certain way. So this is like a really important thing for security, and it's kind of exciting that we have this path to pursue down the road. Basically, that's all from me, so thanks for listening. And if anyone has any questions, yeah, if anyone has questions.
Thank you. Very useful because I'm a content developer and I'm a fan of your platform. My question is it possible to deploy a node in a private network just to explore the technology? Our company don't need to join the public blockchain for now, just a private one just to explore and to build a proof of concept.
Yes, definitely, yes. So we can provide you the node if you want to join our Discord. It's this community here. I don't know if you can see that link or talk to me on Twitter. Definitely I can help you set up a private network. It's actually really easy to do. In fact, maybe we should upload a tutorial for that very soon. But absolutely you could just spin up your own node, maybe your collection of nodes that will all speak to each other locally, yeah.
Another question is about security. Does it integrate with the Active Directory for authentication and so on?
Not yet. I mean, down the road, that's definitely something we could look at. Obviously, that's like Microsoft, there's benefits there, but not yet.